So we're going to look at a little chart here in a second that shows how the sun appears on other planets. And this chart was put together by a place called My Science Academy. It is a mainstream science site. The little spaceship seen in each frame is irrelevant to the overall point. The original designer put it there to help establish how much light the sun generates on each planet. Each comparison was based on the approximate apparent visual magnitude of the sun for each planet, meaning that the little spaceship is going to show you how bright it is, when it looks there. So Mercury, we've got this big old sun in the sky. It's huge, and you can see the little spaceship down here is lit very, very brightly. Venus, it's of course quite a bit smaller, and it's not lit nearly as brightly. Then we get to Earth. You can see what's happening there. Now Mars, interestingly enough, they're showing that that little spaceship is being fairly dark, and remember, Mars has got a whole lot less sunlight than we do, so it's even amazing that they do this. But the sun actually shines pretty brightly on Devon Island, which is really where Mars is, right? So then we look at Jupiter, and then there's Saturn. Remember, 1/100th the intensity, 10 times smaller, and there it is. And the little spaceship is almost in complete darkness, right? So these are the things. And then by the time you get out to Pluto, and they don't even show Pluto on here, but the article that I actually pulled this from that was by My Science Academy says, how does the sun look in on other planets? And it just says straight up, well, by the time you get to Pluto, it's just another star, right? So, and that isn't even a light day away, guys. That's crazy. I mean, they want us to, they give us demonstrations like this, and they have to, based on, their claimed distances and everything. But if the sun in eight light hours, or 2/3 of a light day, is too small to see angular-wise, and brightness is orders of magnitude dimmer, right? How in the world are we seeing stars at, the closest star is Proxima Centauri, right? And that's like 4.4 light years away, something like that. I mean, there's a huge difference between 8 light hours and 4 light years, right? And remember, our sun is an average-sized star. And yet, they're telling us that we're seeing stars dozens, hundreds, thousands, tens of thousands, hundreds of thousands, millions, and billions of light years away. And it's just preposterous. And the only way that they are able to make their math work is they will sit there and tell us things like, well, Polaris, for example, is supposedly, it was 450 light years away. Then, of course, they had to revise it to, I think, 323. So they only had a mere, like 130 light year, just a small error, a mere 130 light year discrepancy in that. So they revised it. So they tell us now that Polaris is about 323 light years away. But its brightness is about 4,000 times brighter than our sun. And they do this, they just make this stuff up so that they can make the math work as we come here. Because remember, they have no way to measure this. It's all a mathematical construct to them. There's nobody that has ever been there that has actually measured the size of Polaris, and nobody has ever been there to measure the brightness of Polaris. But, they will have you believe that somehow, without knowing either one of those things, that they can tell you everything about it, which is preposterous. They simply cannot. All right? So just some things to think about, about when you look up at the stars in the sky and what they tell us, how far they actually are. I mean, the notion is ridiculous, frankly.